Hey guys, and welcome to this video. In this video, I'm going to talk about the OSI Layer 1, or the physical layer. Let's quickly recap what we talked about in the last video. So in the last video, I gave an overview of the OSI model. And the OSI model is an open, vendor-neutral networking model. It was created by an organization called the ISO. They used standardized protocols, either define them or pull them from somewhere else. And as a result of using standardized protocols, it increased interoperability among different vendors. The OSI model follows a 7-layer architecture, as you can see on the right, starting with layer 1 at the bottom to layer 7 at the top. Starting at the bottom, we have the physical layer, then the data link, the network, transport, session, presentation, and application. Several rules are followed in order to make this layer architecture work. So each layer provides a service to the layer above it. Each layer at the source interacts with the same layer at the destination. A process called encapsulation is used to package up data to be passed to the layer below by adding headers and trailers. And decapsulation works the opposite by removing headers and trailers and processing them. And lastly, a unit of payload plus the header and trailer for that layer is called the PDU, or Protocol Data Unit. And we give special names to the layer 2 and layer 3 and layer 4 PDUs. The segment is a PDU of the transport layer. The packet is a PDU of the network layer. And the frame is a PDU of the data link layer. So let's talk about the physical layer. The physical layer defines the electrical, physical, and mechanical specifications required to physically transmit data, and it is a bridge between the digital and physical worlds, as it literally takes digital data in the form of bits of binary data and transmits it in the real world. Recall that the physical layer is at the bottom of the OSI model, and hence it technically provides services to all the layers above it, even if it does not directly interact with the upper layers. This serves as a reminder that the upper layers are very much dependent on the physical layer, and any issues in the physical layer can potentially affect the layers above. The physical layer actually contains many components. You have connectors and pinouts, transmission media, signaling, encoding, network interface card, topology, and more. Connectors are used for the physical interconnection of devices, and pinouts define the function of each of the pins. And as you can see on the picture on the right, you have an example of a connector, and the metal strips are the pins of the connector. The transmission media is the physical materials used to transmit signals, and there are two types. You have wired and wireless. For wired media, the specifications define things like the type of material, the thickness of the material, and things outside of the main transmission media, such as insulators, jacket, and shielding that help prevent some of the issues of transmission. And there are two main types of wired media, the copper and fiber. And as you can see on the picture on the right, and on the top, you see an example of a copper cable. At the bottom, you see an example of a fiber cable. For wireless, the specifications might define things such as antenna specifications, channels and frequencies, and channel bandwidths. In order to transmit digital data, we need to turn it into a signal. A signal is basically how digital data is represented in the physical communication channel, and we use a set of techniques called modulation to generate those physical signals from digital signals. And demodulation does the opposite, where it turns physical signals back to a digital signal. And a device called the modem performs the modulation and demodulation, and that word comes from taking the first few letters of modulation and demodulation. Encoding at the physical layer is how raw digital data is represented so it can be transmitted in an efficient way. And we'll see that encoding techniques exist in more than one OSI layer. And decoding is the opposite, by turning the encoded data back into its raw digital data. Combining it all together, we have something called the network interface card, or otherwise known as the NIC. A NIC interfaces with the rest of the device and brings the data to upper layers of the OSI model. And it contains most of the components we've talked about, such as encoding and decoding, signaling components such as amplifiers, LEDs, lasers, and signal processors, and an interface with the transmission media such as a connector. And as you can see on the picture on the right, we have two examples of NICs used in the real world. On the top, we have a NIC that's used for Wi-Fi or wireless communication, and at the bottom, we have a NIC for wired Ethernet connections. Now, we do live in the real world where everything follows the laws of physics, and the laws of physics leads to a lot of problems in signal transmission. So we have reflection, where a signal gets reflected or bounces off a surface. You have scattering, where a signal gets scattered or expanded into multiple signals. You have refraction and diffraction, where the signal gets bent or changes direction. You have attenuation, where the signal gets weaker. You have crosstalk, where different signals might interfere with each other, and many, many more. The design of all the components within the physical layer helps either reduce the amount of errors or eliminate the errors altogether. Through careful design of physical layer components, engineers have been able to achieve transmission over longer distances, transmission at very high speeds, and a greater ability to reject interference. Something that's not defining the specifications is a topology. A topology basically defines the physical arrangement of devices that are connected to a network. Here are some examples of topologies that are used in networking. You have the bus, where you have one cable connecting all the devices. You have star, where you have one central device, and that central device connects to all the other devices. You have a mesh, where all devices connect to all other devices. You have a ring topology, where each device connects to two other devices, and putting together forms a loop. You have a tree topology, where you start with a device at the top and then you connect them together like branches of a tree. And you have point-to-point or point-to-multi-point, where in point-to-point you connect one device to one other device, and in point-to-multi-point you connect one device to multiple other devices. Each topology has pros and cons, and you can consider topology from a cost perspective, from a redundancy and resiliency perspective, from a management perspective, or sometimes you just don't have a choice. So when you're designing, you need to consider all these factors. These are not the only topologies that can be built, so I encourage you to go out and learn about other topologies and the pros and cons of each. Some real-world examples of the types of physical layer infrastructure that's deployed are the wires coming to your home, for example, deployed by your internet service provider. You have cell towers that are provided by cell phone providers. You have undersea cables that are deployed by companies looking to provide intercontinental traffic, and satellites orbiting the Earth. Now, I mentioned in the problem section that the physical layer is governed by the laws of physics. So in here, I'm going to go beyond the network specifications because I don't think it's enough to just talk about network specifications at the physical layer. In the real world, you have physical equipment that is stored physically somewhere. So it could be in a data center or a data room, it could be in equipment racks. You need to deal with providing power to these equipment. You may need to deal with environmental conditions, for example, the weather, temperature, humidity, and smoke, and there's many, many more. And I personally believe that the physical layer is much more than what the specifications define about cabling, the signaling, and the encoding, and so on and so on. So I'm going to leave a link in the description below. So there was an incident where a cloud provider in France lost their data center due to a fire, and it is definitely a good read and a good reminder that the physical layer goes beyond networking. There are several devices that operate at layer 1. One is called the hub, and the other is called repeater. A hub contains several ports, and when data arrives at one port, it is copied to all other ports. Now, a repeater generally contains two ports, and the incoming signal gets amplified and sent out the other port, and that is to extend the range of the signal. These are some of the references that I used to make this video, and that's it. Hope you guys all gain a bit more appreciation for the physical layer. Please like and subscribe and leave a comment down below. Let me know what's the most interesting thing that you learned through this video, and let me know what kind of security issues do you see happening at this layer, because we're going to talk about security issues in a future video. And thank you all, and I'll see you in the next video where I will talk about OSI Layer 2, which is the data link layer.